Okay, let's continue on our exploration of how R creates your design matrix. So the next one I'm going to cover is the plus. I mean, you've seen this so often, you probably haven't thought about it. But what we're doing when we do plus is it's to some extent it's just going to create two lots of design matrix and then just put them side by side. That's all it really does. So for example, if I had here a categorical variable alpha and a categorical variable beta, what it would do is it would do that standard representation. It would choose a reference case for alpha and do the 0, 1s, the reference case for beta 0, 1s, and it would put those two side by side, and then it would also shove in an intercept. And it would make sure there's only a single intercept, because each of those metals on their own would give an intercept, but it's clever enough to look and go, you got two columns of 1s, we only need 1, and that's it. And we'll see that in when we get to the code. So, we've also seen this in parallel regression. So in parallel regression, what we're going to do is we've got a quantitative variable, which we'll call x. We have a factor, a categorical variable, which is represented by our alpha. And what we're doing in parallel regression is you can see there's a single slope to get the relationship between our expected values and our continuous predictor. We've got an overall intercept, and then we have extra bits for each different group. So because we set the alpha 1 equals 0, this will be the intercept for the group where our categorical is level 1, and then the other ones will be above and below, but all of them will be represented by parallel slopes, parallel regressions. The next thing we're going to do is the colon operator. The colon operator creates interactions. So anytime if I have A colon B, it's going to create all interactions between these two things. If they were two continuous, there would be a single extra column, and the way it would do it is it would do an element-wise multiplication of each of those things. If it's one of them's a factor and one of them is a continuous, what it will do is for each of the columns that represent my categorical, it will multiply it by my continuous variable. And again, it's one of the things, look at the code, it makes more sense. So for example, if I wanted to model factor of interaction with that, I could go, I want an A. Now often, just so you know, one of the terms we use is where we have a term on its own like this, we often refer to it as a main effect. And then we will have this, we will call a two-way interaction because it's got two main effects in it. So predictors on their own are often called main effects, and this would be a main effects with two-way interaction model. And what this will do is it will classify my A in this case is the categorical, so it will set up basically them 0, 1 columns in the appropriate way, the same for B. And to get the AB, it will take every column for A and every column for B and multiply them and give it a new column. And you've seen this before with the separate regressions. In this, what we've got in our separate regression, we've got the intercept for level 1 plus the extra intercept for each of the other levels. You've got the slope for level 1 plus the extra slope for each of the levels. And the way we do that is we go tilde A plus X plus A colon X. What does the multiply operator does? It's a shortcut. This is a pain to type, especially if I wanted multiple interactions. Let's say I had, x1, x2, x3, x4. I don't want to start writing all this. So that's what this does. This basically says, I will give you all the interactions that are possible. So for example, A times B expands to A plus B plus A tilde B. A times X is A plus X plus A tilde X. And in fact, if you had A times B, it would go A plus B plus C plus A times colon B plus A colon C plus A B colon C plus A intersection B intersection C. Because you have three terms, it will give you all the possible interactions up to three-way interactions. So there you are. I should have just shown you this rather than trying to say it all. So the multiply, if I go A, it goes A plus B plus C, so these are my main effects. Then I've got my two-way interaction effects and my three-way interaction effect. Make sense? Good. What does the hat operator do? basically it takes this and it times it by itself, and then it goes and does that multiplication where it will replace any multiplication with interaction terms. Where it's really, really useful is, let's say I have, for example, A, B, C, D, and I want a model that will have all the main effects and all the two-way interactions, but I don't want the three-way interactions, the four-way interactions. That's what this gives us. This, when it multiplies, goes A plus B plus C plus D plus AB plus AC plus AD plus BC. This is basically up to all interactions that are two-way. So that's what that gives you. That hat 2 is a quick way of saying, I want interactions, but I only want them up to 2. So if it was hat 3, it would be, give me all the ones up to three-way interactions. It's a really nice shortcut. Almost no one knows it, and it's brilliant. The minus operator basically means that I can remove something that's already in the model. The classic one we do is if we want to remove the intercept. So if I want to remove the intercept, I would basically go do tilde x. That would automatically give me an intercept, so I say take it off. So you can often take off extra things. So you could have done your model with the three-way interactions, the A times B times C, and then say now take off the three-way interaction. That would give you 2A. But you know a better way of doing that now. It's also clever. It will look at things. So if I go, A plus B minus A plus A, it sort of goes, well, you've taken off A and added A. Yeah, it's just plus A. So it tries to be clever. So if in doubt, look at the model matrix and make sure it's doing what you want. The nested operator is interesting. The classic example and the time I use it is, when we do our separate regression model, and to work out the slope for each of your groups, you have to sort of take the overall slope and then add or subtract the coefficients. It'd be nice if you could just get that slope directly. That divide operator gives you what we call nesting, and it makes it easier to read that off, and we'll see that. So now we've got that, let's look at some examples. So we started doing this last time. I'm going to set up some data. We've got some data here. And what my data is, if we look at it, is we have a first categorical variable A, and it has levels cat, dog, rabbit. We have another one which has levels apple, banana, pear. So if you can see that subject A is cat, apple, we've got a predictor which is just numbers, which is 1, and has this response variable. So you can think of this as favorite pet, favorite fruit, I don't know, number of times you've watched an episode of Game of Thrones. Say, don't care. Next thing I'm going to do is I'm going to make sure that it knows that the categorical are factors. So that's what I'm doing here. Let's read what it says. Mutate. So you're going to make new columns. Across says, I'm going to tell you which columns to do. Where any column is a character, convert it to a factor. So we do that. And now when we look at it, you can see that before they were characters, now they're factors. I put that in, like you go, well, I could just go mutate A equals factor A, B equals factor B. But as you get bigger and better, you're going to have data sets where you have thousands of predictors. You don't want to be typing them in. Starting to learn more tidyverse commands helps. So the first thing is, what does this do? If we do model maker, it's A plus B. Basically, it created the first 3 rows were basically the representation of your favorite pet. This row plus the intercept would be the representation of your favorite fruit. It put them together and went, well, I've got 2 intercepts, I'll get rid of it and I'll leave a single one. So you can see here that this first one is a 1, 0, 0, 0, 0. So obviously the favorite animal is not a dog or a rabbit, hence it must be a cat, because that's the first one alphabetically. It's not a banana or a pear, hence it must be an apple. With these ones, you can see with this particular row 2, it's not a dog or a rabbit, so it must be a cat, and yes, it's a banana, is their favorite fruit. Nice and easy. If we did A plus X, so all it's done now is it's taken the block that we would have for your favorite pet, and it's put an extra 1 in because this is just a continuous variable, so it's nice and easy, just put in an extra column. What if I do A plus A? It just did it once. It went, I'm not going to do it twice. It can't do it twice. If you think about it, if you did it twice, it's definitely not independent columns. So it just looks in it and it basically takes it into account and says, you can't do that. That's just equivalent, as far as I'm concerned, to tilde A, so I will give you tilde A. Let's now do our interaction term. So you've got your A, your rabbit, and your dog. So we know about that. You got your banana and your pear. So how did it get A dog? So this is the interaction between the column A dog and the column B banana. All it did is it went to this column and it multiplied it element-wise by this column. So it went 0 times 0 is 0. 0 times 1 is 0. 0 times 0 is 0. 1 times 0 is 0. 1 times 1 is 1. Oh, I got something interesting. So this is the one, out of the whole thing, this is the one where the favourite animal is dog and the favourite fruit is banana. It now does the other combinations. Altogether, there was 3, so there's 1, 2, 3, 4 possibilities. Because there was 2 columns here and 2 columns here, and 2 by 2 is 4. And each of these columns is just basically, they go and find the appropriate columns and multiply them element-wise. Same thing if we do the interaction now. Here's our columns. To get A dog X, it took the A dog column and the X column and it multiplied them. So 0 times 1 is 0. 0 times 2 is 0. 0 times 3 is 0. 1 times 4 is 4. And basically you can see this is all zeros except for the few places where your favourite animal is a dog. This is all zeros except for the few places where your favourite animal is a rabbit. And it's just getting each of these columns. Altogether we've got 1 column here. We've got 2 levels here, so there's altogether going to be 2 interaction terms. And that's all it's doing. It's just doing multiplication. Let's have a look at our operator in this case. So I'm doing A times X is pretty well identical to what we saw before. This is your standard case where you're looking at doing separate regression. So this coefficient will give you the overall slope. This will give you the extra slope when your favorite animal's a dog. This will give you your extra slope when your favorite animal's a rabbit. All fine. Let's see what this divide does. It's what we call the nesting operator. Now, see this column here, the X has disappeared. And these 2 columns look the same, but now it's got an extra column here where basically it's the value of X when your favorite animal is a cat. So basically, instead of having all of them and then the extra bits, it has 1 column for when you're cat, 1 column for your values of X when you're dog, and 1 column for values when your favorite animal is a rabbit. What does that mean in actual when we fit the model? Well, here is the summary of our linear regression. So by now you should know this. If I wanted the intercept of the slope when it's a cat, it would be minus 0.3. If I wanted when it was a dog, I would go minus 0.3 plus minus 4.9 would give me my intercept. If I wanted the slope for a dog, well, first of all, I'd take the slope here, which is the slope when your favorite animal's a cat, 0.123, and I would add the 0.68, and I would get something that's about 0.8. Yeah. But you have to do that calculation by hand. This is where the nesting operator comes in. Now, if I do this, you can see that here is the cat slope, the 0.123, 0.123. Here's now the dog slope, the 0.80, which I said this plus this is about 0.80. If I took this and added this, I would get minus 1.2. So the advantage of this is I can just read the slopes off directly. You could do that with intercepts if you think about carefully what you would do. You wouldn't use a nesting operator, you'd use another operator we did. I'm not going to give it you. Have a think about it. If you work out with the answer, let me know in the next tute or prag. So that's it. That is all the different sort of functions, not functions, but operators you can use to design your design matrix. Next lecture, we're going to actually do a case study. We're going to go and look at that poison data and actually do a full analysis of it. Okay, see you next time.